Hey everyone, and welcome. If you're just starting out with Java, you've almost certainly heard people talk about Object-Oriented Programming, or OOP. Now that might sound super complicated, but trust me, it's really just a very clever way to organize your code. Today, we're going to break down the four main ideas that make it all work. So, let's get into it.
So let's kick things off with a big question, right? How can we get our software to understand and work with things from the real world? You know, things like a car, or a person, or maybe a bank account. How do we represent those inside a program? Well, the answer is, you guessed it, the whole object-oriented way of thinking. It's all about making digital models of real things.
So here's what we've got on deck today. We'll start with the big picture. What is OOP? Then we'll get into the absolute basics, classes and objects. After that, we're going to walk through each of the four main principles, one by one: encapsulation, inheritance, polymorphism, and abstraction.
All right, first things first, let's get right to the heart of it. What in the world is object-oriented programming?
Okay, so at its core, OOP is really a mindset. Instead of just writing a huge long list of commands for the computer to follow, you build your program around these little self-contained things called objects. Each object is a stand-in for a real thing, and it holds both its own information and all the things it can do.
Now, to really get OOP, you have to get your head around its two most important pieces, classes and objects. The best way to think about them is like this. One is the blueprint, and the other is the actual building you construct from that blueprint.
And I'm not kidding, understanding the difference here is like the first major hurdle. Once you get this, everything else starts to click into place. One is the template, and the other is what you make from that template.
Okay, this table breaks it down perfectly. A class is the blueprint. It's the idea of a car. It says, okay, any car we make will have a color, a model, and it will be able to do things like drive or brake. It's just a concept, right? It doesn't take up any memory. An object, on the other hand, is the actual car you built. It's a specific red Tesla or a specific blue Ford. It's a real thing that exists in your program's memory, and you create it using that special new keyword. So you only need one car blueprint, but you can create thousands of unique car objects from it.
All right, let's tackle our first pillar, encapsulation. This one is all about security and organization. Think of it like creating a protective bubble around your object's important information.
So what this means is we basically wrap up an object's data, its attributes like a person's age or name, and we bundle it together with a code that can actually change that data. This is awesome because it stops other parts of your program from just reaching in and messing with things they shouldn't. It keeps everything neat and protected inside one single unit. And this image of a capsule, it's the perfect way to think about it. The important data is tucked away safely inside. If some other piece of your code wants to interact with it, it can't just barge in. It has to go through these official doorways, the public methods that you've created. This gives you, the programmer, total control over how your object's data is used.
Okay, moving on to pillar number 2, inheritance. This one is a game changer because it's all about being efficient. Why reinvent the wheel if you don't have to? It lets us build on code we've already written.
So, inheritance lets you set up this kind of family tree for your classes. You have a parent class, and you can create a new child class that automatically gets all the features and behaviors of its parent. This lets us make specialized classes based on more general ones.
And the magic word here is reusability. So let's say you have an animal class that knows how to eat and sleep. It'd be crazy to rewrite that code for a dog class, and then again for a cat class, right? With inheritance, you don't have to. They just inherit those traits from animal, and then you can add new, more specific things, like a bark method, just for the dog. It saves so much time and effort.
All right, next up is a big one with a fancy name, polymorphism. It sounds intimidating, I know, but it comes from Greek and literally just means many forms. And honestly, that's the perfect way to describe what it does. And this, my friends, is where your code starts to get really flexible and powerful. Polymorphism allows a single action or a single method name to do different things depending on which object is performing it. So you could have a whole group of different animals, and you tell each one to make sound. The dog object will bark, and the cat object will meow. Same command, different behaviors. It's pretty cool.
So in Java, there are two main flavors of polymorphism. First, you have overloading. This is when methods in the same class have the same name, but they take different inputs or parameters. The other one is overriding, which is what we were just talking about with the animals. That's when a child class takes a method it got from its parent and provides its own unique version of it. So the dog class overrides the general make sound method from the animal class.
And that brings us to our fourth and final pillar, abstraction. If encapsulation was about hiding data, this one is all about hiding complexity. It's about making things simpler to use.
Basically, abstraction is the art of showing only the essential stuff and hiding all the complicated, messy details that are going on under the hood. It lets us interact with complex things in a really simple way.
You know the best example of this in the real world? A TV remote. When you press the volume up button, you don't know, and you definitely don't care how it's sending an infrared signal or what's happening in its circuits. You just care about what it does, making the TV louder, not how it does it. And that's exactly what abstraction does for us in our code. It lets us use objects without needing to get bogged down by their internal complexity.
Okay, so let's do a super quick recap to see how these 4 pillars work together as a team. You start with abstraction to come up with the general idea of an animal. Then you use inheritance to create more specific cat and dog classes from that idea. You use encapsulation to keep the internal data of each cat and dog safe. And finally, you use polymorphism so that when you tell each one to make sound, you get a meow or a woof. See, they all work together.
And there you have it, encapsulation, inheritance, polymorphism, and abstraction. These 4 ideas are, without a doubt, the foundation of not just Java, but so many other modern programming languages. They help us write code that's cleaner, easier to reuse, and way easier to manage. So now it's your turn. Take a look around you. What's the first object from your world that you'd want to try and model in code?